Should we kick it off? Okay, thanks for coming. I'm really happy to have Philippa Gardner here talking about some exciting work with JavaScript verification. So I've known Philippa for, I think, more than a decade, probably. So we were both in the kind of London, Cambridge program verification community. I think that it's really exciting that a lot of those people from that community have kind of gone off to doing, even sort of bigger and more impactful stuff. So, people like Byron Cook, of course, and sort of Peter O'Hearn. And in Philippa's case, she's done this amazing stuff with kind of like trying to sort of take a kind of real and kind of very gnarly and disgusting kind of object, namely JavaScript, and then trying to sort of do nice principled kind of verification with it. So I'm really excited about this work, and I think it's going to be a great talk. So yeah, take it away, Philippa.
Thank you, Mike. And hello, everybody. I just love this room. Max, that way and that way. Let's see how it goes. If I'm ignoring anybody, you just go, oi, and I'll stop. So I've got this talk, but please ask questions as we go, and I'll just adapt. I'll stop at 12, whatever's happening. And it'll also give me a chance. So there's my two postdocs here, Petter and Jose, and their remit is to answer your questions better than I will. So we'll see actually what happens. But at the beginning, so basically I'm going to do a real technical talk. But for the first 10 minutes, I'm just going to show you a little bit of who I am anyway, because there's many of, I don't know many of you. So at the beginning, it will be quite light, and then we'll get to code. So first, something completely off the wall. The UK is funding a few of us, 4 of us, in particular me, to be an advocate for analysis and verification in the UK. What does it mean to be funded? It means to be funded by the equivalent of the NSF and NSF. So the equivalent ones to do it. And for me, this is very attractive. It's only a hobby. I do real technical work. But I don't have to be an organizer in the department, like director of research. I could be an advocate for my subject, so I quite like that. And, but also, I think we've got a real job to do. In my academic work, I'm always asking, what does it mean to get my theoretical work into a pathway to be useful somewhere? And then, okay, it isn't a theorist, but it's a tool developer inside academia, what does it mean to get them to do more than just that prototype tool? And from the point of view of real hardcore people wanting very engineered tools inside academia, what does it mean for them to do the startups embedded inside the obvious one being Facebook or whatever it might be? And how does one facilitate some of that? And then what does it mean to be in industry, being really interested in analysis and verification, having some sort of streamlined process for their particular company, but wanting to know where the new stuff is and how it's going to evolve and be interesting. And then from the point of view of the companies such as working with general programmers, we've got some success stories inside Facebook, Amazon, Google. But actually, there's a much wider group of industrial companies doing working with general programmers who want to do good code. So what does it mean to get some of the communication going between these various forms of people? And then there's Galois, which is this extraordinary place of being part of that interaction. And so we don't have that Galois equivalent in UK or what have you. So what does it mean for me to understand something of what's going on inside Galois? That's my remit for this afternoon and then for lunch and what have you. But also here, what does it mean to do something? So in particular, I wanted to say one thing. I'm hooked up with Steve McGill. John went to, was very prominent in a meeting in the Royal Society in Imperial to do with launching this thing. And we have, each year we have a meeting where the point is to get academics and industrialists together to do this sort of thing. And Steve McGill has sort of said yes to being a speaker next year, but yes in the context of it's January and it's happening in September. So it's yes, I'd like to, and then will it happen? I don't know. But in particular also, he's got lots of plans for future, and he's wanting to advertise to the UK people interested in analysis and verification. And what with Steve and others, what we want to set up, we want another button there saying jobs, and we just want a list of companies with a link, for example, a Galois link, and you guys sort out your own link. It's up to you what you say. And it's just a place where the PhD students and postdocs can go, because I'm very aware in my group, I've got amazing PhDs and postdocs, and if they do the academic route, I know how to advise them. And if they do the industry route, there's all these different forms of industry and what's it mean for them to fit and what have you. And part of this is to get an environment where they can go exploring. This is my fabulous group. I do some concurrency, and the point of this slide is to embarrass Mike. So, we've got a wiki agrees, rely guarantee, concurrent separation logic, that's Pete O'Hearn, Gödel Prize stuff. There's rely guarantee reasoning connected to separation logic, that's Victor Vafeidis, who got the Sigvad Dissertation Award. Then comes deny guarantee, that's Mike and Matt Parkinson, that this is the Cambridge gang working at this low level of fine-grained concurrent reasoning. And then the Imperial gang came along and went, what about abstraction? And ended up here. And this is a little bit of an old slide now, but it is, this has spawned some stuff, including the Iris stuff that was a killer in Popple this year. That's sort of totally hitting. And, you know, this was really pivotal. And this was very much Mike and others. So, and here, from CAP, we've got a tooled caper that started at Imperial and went to Arcus. Basically, it's Thomas Dinsdale-Young, who's my PhD student. And that caper is now being taught, is now being really explored in a Facebook workshop coming this week on concurrency, where Pete O'Hearn, Magic Michael, what's it mean to do these real concurrent algorithms and verify them using some version of tools. So this is one version of what I mean to be an academic in this sense, working with tiny concurrent algorithms, but doing it in such a way that the reasoning is compositional, and so we have a pathway to somewhere else. So this is why I wasn't just embarrassing Mike. But the real thing I want to talk about today is with my other hat on, which is JavaScript verification. And this is as large and as big as it comes, but the point is to do it in such a way that my theory head doesn't get very upset. So let's see how that goes. There's been a bunch of work, and I wanted to put up this slide just to explain a little bit of where I am. So I really have come from the theory world, and in particular supervisor Gordon blocking, you know, very thin. Here I did little, what does it mean to do a separation logic for a small fragment of DOM? And I thought that was enough for a pathway, in that I'd done some work before, and then I'd sort of really connected it to DOM updates that seemed to be the right application area, and I thought I was going to stop and have nothing to do with any of this. But what happened was that we had quite a lot of response to this work, of the order of, Philippa is a theorist, this won't work in practice, do a little tweak of her work and get another paper. There was a lot of that happening, and I was actually getting a little bit irritated. So this Smith thesis does DOM core level 1, 19 pages. And we went to there and we didn't go further, because what does it mean to want to go further now? So what I think we've done enough to show the reasoning didn't change. We've spent 2 years working out what on earth a spec meant. And so we've done enough to show some version of scalability, but that doesn't mean that we've done enough to show that we can do that beastly DOM thing that keeps changing. So then, where should one stop and how should one be there? We stop, we do some work here, and do we hook it to this other world? We don't know. We could. And what's it mean to have an incentive to do it? Is it our job or is it other people's jobs? Don't know. So this is just to say the concurrency work actually has a lot of impact on this sequential JavaScript work, because everything I do in concurrency has impact on the sequential stuff. Quite often we don't highlight it because it's easier to get papers saying concurrency than it is to get sequential. So, but this is always happening. And we worked here on this tiny fragment, to show it's possible to reason about the variable store emulated in the heap for JavaScript. And for example, TypeScript took our fragment and showed that there's an underlying safe bit of their TypeScript and did some analysis of what was safe and unsafe. So there's a little bit of a pathway to somewhere else. But at the same time, this was fragment. And in particular, if we have assignment for JavaScript, that assignment is expression 1 gets assigned expression 2. So it's not even variable gets assigned expression. So it's expression 1 to expression 2. The expressions are difficult, complicated. And also, they call get value and put value functions. The get value and put value functions have tens of cases. The expressions are complicated. So you have hundreds of pathways through the standard of that order to say what it means, what assignment means. You're not going to write hundreds of logic rules. So where do we go from here and what does one do? And that's the point of this talk. Never mind that I'm working with JavaScript. It's actually about, given a big language, given my or the community's theoretical thoughts, what does it mean to bring those thoughts into this big analysis without compromising, but at the same time it's big, so what does one do? And I'm going to tell you about this bit. Excuse me, can you guys see if I'm here? Are you okay?
Not always, but let's move this thing so that you can stand further to the left if you want.
Yeah.
Good.
Better. So I'm going to talk about this. This was at the Popple just gone, and this other stuff is new work on the way. We haven't submitted it yet. So basically, I'm going to talk to you about JavaScript Verification Toolchain. This is why you should be looking at JavaScript or thinking about JavaScript. It is the most active language on GitHub and Stack Overflow at the moment. We know it's useful for a website. And we are, at the moment, and I didn't even expect this, we're doing a semi-automatic verification tool for JavaScript based on separation logic. And I thought I was going to go kapow and do JavaScript info. I thought I was going automatic. And we will be going that way. But we actually found ourselves interested in this bit. So we're staying put here for the moment. And we're aiming at the specialist developer wanting rich, mechanically verified specifications, and how well can we do to help. The developer will need to do some annotations, so that means many developers aren't interested. We understand that. But it's where we're staying for now. And we've got 3 challenges that we very much like. What does it mean to design specification so that the developer understands? There's a lot of stuff going on in JavaScript under the hood that I don't want bubbling up. I want to be able to give it in a language that the developer understands. The verification challenge is to understand this sheer complexity and how to do it without simplification. And then there's something that doesn't always happen, which is a validation challenge to understand what it means for the verification to be trusted. And for this is so that my theory head doesn't go mad. So we're on code. I'm going to try the other side. That's better. It's the reflection. So for this code, we've got the map function. So basically, if you know about objects and functions, you're fine with this code. It doesn't matter that you don't know JavaScript. There's a little bit to tell you, but not much. And we're very proud of this example because this example is a stylized version showing what's going on, and we like it. So we've got a map function, and it creates a map object. And inside the map object, you have a property field, a property that points to another object that at the moment is empty. It's not empty, there's some internal stuff going on, but you don't need to know about that from the point of view of the developer. So you can declare it as this empty object. And the point of this contents object is that it's going to do something very JavaScripty, which is going to have the properties or fields as the keys and the values as the values of these properties. So it's going to use this object as the list of key value pairs. So one thing that we have is very much extensible objects, not the Java objects. So Java objects, you've got a very static thing. You know exactly what properties or fields are there and what aren't there. Here, you don't know. Things are fluid. I'm going to go through one more bit of code. I'm not going through any more, so I'm not going to get too heavy on that. So the next thing that happens with JavaScript, instead of classes, we have prototype inheritance. And prototype inheritance is just telling you where to go looking for the methods. And there's a pattern to go looking for the methods that's a JavaScript thing. So, and there you find the get, put, and key value. So if we walk through this function, get takes the parameter key, and it looks at the content object, and it asks if the content object has the property key. And it has to ask, because don't forget we've got extensible objects. So there's has own property, which is this global function, so that you can test whether or not a property is in an object. And if the key is there, then you return the value. Otherwise, you return nothing. So we have dynamic property access in the sense that we are not just working with names of fields. We've got expressions that get evaluated to the property that is needed. Finally, you've got all manner of stuff under the hood that this code doesn't show, but any JavaScript programmer in the room knows that there's a lot of it, and I'll be showing a bit of it. And that is just everywhere. Every time you call an assignment, every time you call the get value and put value function, there's a lot of stuff. And the point, yeah?
Can I ask a framing question? For years in the Java universe, everyone said, there's this thing called reflection. We won't deal with it. We don't reason about it. It's a mess. It's horrible. It's hard. And now suddenly we're working on Java. Can you explain that phase transition?
No. No. Reflection's just embedded. Why are they happy now when they weren't happy before?
Yeah.
What does it mean for that low language to hit? Why should such a ridiculous language hit? But on the other hand, sort of actually very interestingly, there's a real research question of what is this reflection doing and what's going on there. So from the theorist's point of view, there's actually an interesting question. But why should the programmer, that's not my answer.
So the corollary to it is it if we solve good problems about JavaScript and we build those, and suddenly we can read about this reflection in Java, the core theoretical ideas.
I'm not making that's too hard for me because I'm not doing.
Maybe it's somewhat related. So these things look as weird as objects. But I never thought of them as objects. I think of them as maps in the first place. And you can just think of these things as maps. And we just implemented a map in terms of a map. And maps are not that unusual, right? You can extend them, that's what they're for. Is that a reasonable?
I think that's fair, and it's just a word. So they tend to be called extensible objects.
Right, but maps we know a lot about.
Yeah, so in particular, there's lots to your question. So absolutely, we are just, this example is lovely. And this example is, there's Joseph's example is just getting to the heart of how these objects are getting used. So that's how I think of it, and that's why I like it. But but also, a lot of what I'm saying, if you were doing something more normal in terms of how you're working with objects rather than this, a lot of what we're saying would apply. So I'm only choosing one that gives a little bit of the spirit of JavaScript. If you want to stay in a normal fragment that looks as much as possible like Java, you're still going to need what I'm going to say. So we've got two challenges. Well, three. A specification challenge, what's it mean to design specifications so they're readable for the developer? A verification challenge, to handling the complex nature of what's going on, and this validation challenge. I'm on the specification challenge first. I'm going back to this example. So here I've got a little stylized bit of memory created by working with these functions. So we've got a map object which contains the contents property pointing to the object called contents. And inside here, we've got some of these key value pairs. And then something that is very much to do with the structure of JavaScript is that you have an internal property. I use this at to just mean internal. And this gives the prototype chains, giving you the prototype inheritance, showing where to find the methods. So for example, you can see here, there's this pattern of map.prototype. Here's the map.prototype, and it's an object where the methods are. And every object, the sort of default is that every object, if it doesn't have this sort of structure, it points to object.prototype. So these two are going to object.prototype, and this is where you have the sort of global methods, meaning this has-on property that is useful for all objects. So the way things work is that when you want to find a method, you create a map object, and you start looking down the proto chain to find out what you need. And we can break this library in many ways. And I want to do a verified specification that says you can't break the library. That's my goal for today. So here is one way to break the library. And that is, there's nothing in JavaScript stopping you overriding this get here by putting a get up here and doing whatever you like with it. So from the point of view of the library developer that wants a client to use their get, that would be a horrible thing. So for the purpose of this talk, I'm going to say, no, we don't want that. And we don't want that, and we're going to specify that we don't want that, i.e., we're going to give information saying, no, these nones, it's come from concurrency actually, this stuff. These nones are appropriate for these properties. And it just says, if you want to use that library well as intended, this specification is saying, don't put this stuff in here. Unless you're JavaScript aficionados, don't look at this. Don't read it. So another way you can break the library is that you're able to say here, contents is unwritable. And if you do that, you can't create any map objects. So that would be a silly thing to do. So if you want to protect the client from doing that, you can make the statement, no, don't put a property here that overrides the contents because you're using it in a different way. And you put it here and here. Because otherwise you can walk along the prototype chain saying that you check these things, going, contents unwritable, okay, so I'm not allowed to do that. Put it in here. So things have a way of breaking, yeah?
Wouldn't the field reference first be resolved to the actual contents on the object? And
no, this is the way it works is pretend you haven't got, so this is maybe a little bit confusing. Pretend you're creating a new object.
Mm-hmm.
You're creating a new object, and that object points to the proto chain.
Oh, okay.
Before you do it, yeah. I'm sorry if I wasn't clear. So what we're doing with these specifications, we're trying to pull out these properties, general properties that these specifications are going to be able to say something about. And in particular, we want that constructed objects don't redefine properties that are to be found in their prototypes, meaning those prototypes are there for a reason. And prototypes can't have non-writable properties that need to be present in the instances. So that seems quite a nice thing to want. It's not something that you can get without putting extra stuff in, and we put it in through our verification. So let's actually do this specification and see what's happening. I need to build up the abstractions a bit. They're very simple. It looks hairy because we haven't honed things to make it look beautiful, but it is simple. We have an abstraction which is a JavaScript object. A JavaScript object has an address O and a pointer to the prototype chain. So that @proto has value P. What that actually means is a little bunch of stuff that is the sort of default setting for developers. So normally when you've got something like this, you've got an object and it's an extensible object. It is possible to start saying you've got an object and it's not extensible and start putting more conditions on. You're also able to say, I haven't just got an object, I've got a string object or an array object, and get more subtle with it. But from the point of view of, one could be coarser or less coarse depending on what's going on. So we've just got, here's an object, and we have a default, and that default's known to programmers. We have a data abstraction of, here's an object, here's a property, here's a value, and actually there's something called descriptors that's much more subtle. And what this data descriptor is saying at the moment is that things are writable and extensible and what have you, and you can start putting falses in there and changing what's going on. But the sort of default one is that one. We've got a function object. A function object has address O, and the places where you find information about the body and information about the scope. So we've got internal properties telling you where to find the body, internal property telling you where to find the scope. And you can have a lot more stuff there that I'm not going into, more resource there, giving information about the function object. And then I'm just saying there's something, you can freeze stuff. So object.prototype, we're going to freeze, so we never have to look in here and say, oh, is that content property field there? We just keep it very simple at the initial heap stage. Here's our map object. Our map object has an address and pointing to its prototype. And this is a set of key value pairs. And because the SMT solver is a bit tricksy, we also need the set of keys. It would be lovely if you didn't need that. And you just build this up using the structures I've been giving you. We've got an object from M to MP. We've got these properties that are the nuns that I told you about. We've got a data property that tells you where to find that contents object. Yeah. That contents object has address C and it points to there. And we've got mathematical stuff going on. We've got other stuff going on here. So here, this is saying. Yeah.
I'm struggling to follow a little just because I'm pretty ignorant of JavaScript and the details. So I'm not quite sure what you're doing here in terms of
right.
What is map? I mean.
Yeah. Can I just back up a sec? I thought that I have told an OO person the little bit of JavaScript that's needed for you to follow this. If I can't make you follow, I can't make anyone follow. So where is this not working?
So I'm not really sure what kind of thing this is when you say it's a specification. Like, are you writing some JavaScript code at this point? Are you writing
No,
your
sorry,
own
I've been
language?
totally confusing. This is logical predicate separation logic.
Okay,
So excuse me, I've done
Okay.
the transition too quick.
okay.
So in particular, here, these red things are things I want.
Statements in separation logic.
And the point is, the point is to get them in the specification because they're not in the code.
Okay.
A related question to that is on the previous slide where you had on the right hand side. Is that the same type of specification logic or?
Yes, I'm sorry, I've gone too quickly over this. So this star is separation logic star. In separation logic, you'll have a heap address points to a value. That's the basic cell. Here I have object and field property points to a value. So I've just assumed a little too much here and not made it clear. And then these get a little bit bigger because of JavaScript stuff, and I purposely didn't say very much about that because you didn't need it.
So again, just in specification logic. So
Yeah.
then you're saying in the JS object OP, again, some very basic things. Is it a conjunction of the 3 lines that you have there?
It's the separation logic conjunction. So it's separating conjunction.
In those 3 lines?
Yes.
Okay. Okay.
And it's meaning you're
And
not
what
having.
does the arrow mean here? It's implication? Or?
No, this is in separation logic is in they would have a predicate x points to v, meaning at cell x you've got value v.
So the cell here is the O proto.
And it's just the extension of that to OO land, and in OO land you've got an address and a property.
Got it. So then it points to, and then the syntax P star, is that P?
No, this is nonsense. This is,
Oh.
it's this, starred with this, starred with
okay.
this.
Okay. I misunderstood. Okay.
How on earth do we guard against that in future? And if I had an
I
and...
was reading that like P had type star.
No, exactly. If I understand exactly, but it's just what's in how embedded one is in one's own notation.
Right.
So in particular, if I'd had an and there of first order logic, you wouldn't have cared at all. And because this is separating conjunction from separation logic, and that star has lots of versions of what it means, it becomes, stars used all the time. Suddenly that's confusing. We need to do something about that.
I've got it now.
We're just going to stop using separation logic notation. We're just going to call it a set or something. We're just going to find a way of saying these are predicates, this is star. Excuse me. And then it gets a bit more complicated, but not fair. Thank you for the question, because I would have had no understanding forevermore. Are we happy?
I don't mind being ignorant.
No, exactly. Everybody else could be ignorant too. I am totally going to adapt the talk. Yeah. Yeah.
So, where is the C part? Is it existentially quantified?
Where's
C?
Yes.
Existentially.
Yes. That's just in the tools. What happens is that anything that's not declared is existentially. Yeah. Thank you for the question. But in particular, you can see these are all just predicates with that star, and it's gobbledygook notation, but it's just saying field property value in various forms.
Yeah.
And then here's a little bit of an abstraction of here's the object and where it's going next.
And the separation operator explicitly saying these are now different pieces.
Yeah, and it's just saying we just don't have to care. They're all disjoint parts of the memory, and that's all that's going on. Yeah. So star just means star means you just don't have to care about any clash of reachability from one place to the other. Just don't go there. So then you can stop thinking about it. Really, it's just these bunch of predicates, and it's all going to make sense given exactly the same intuition as that program developer. Because the point is, you always think of memory, this bit here, and you don't think about the reachability issues unless there's real reachability issues. Yeah. I'm here. This is maths. This is just, this is saying the contents of the object. It's saying which keys and values you have. And this is saying you have no other. And this is saying here you are with this thing, and if you're going to extend, then you'll have to just extend that as part of what's going on. So it's saying what you have now in a way that in Java you don't need to, because you're talking about everything being static. And here you need.
So again, can I now give a high level feedback on
yes.
that here? So one of the things that strikes me is that this kind of pattern will arise again and again. That
yes.
you'll often say, I don't want these things to be overwritten.
Yes.
And so on. So I could imagine you coming up with a higher level statement about something to say.
Yes, a simpler thing, just saying there's some version.
For which this is the meaning underneath.
Yes.
Yeah.
Yes. And I'm doing lots of things here in the sense I'm working with what does it mean to specify this map data structure. Yes, so one could, how does one think about the most simplest thing one's needs? Yeah. Because maybe you don't care about that, you just care about something to do with things being safe.
And there's lots of patterns that will repeat again
yes.
and again.
And how does one even try and begin and find these patterns? Yeah. We're just saying here is a little one, we've done function closures, we're thinking about others. Right. Yeah, and encapsulation. Yeah.
What about none? Is none a JavaScript object, or is it just a symbol?
None is our made-up thing for us, and it came from concurrency. And in the concurrency world, where I was working with set modules, and in particular, either an element is there or an element is not there. For you, those of you who know about the separation logic work, it means you own this stuff. You know what is going on, and what is going on is that it's not there. Yeah? Versus having it, you own it, and you know the value. So it's that extension of the separation of the code. These are brilliant questions, because I'm going to make this better by having done this. We found. I'm not going to go over this one in the, for time, but basically one has that map one, and that map, it's that abstraction of both the map object and the contents object. And this map prototype object, we're keeping it separate for the moment, because if you've got two objects, you've got to refer to them, and so there's some sharing going on. We actually know how to do technical stuff to hide this within this, but we haven't, that's real technical work, we haven't done. But the point is, given that lots of objects share it, we're going to make it explicit for now. Does the developer want it explicit? Does the developer, is it quite happy to have it inside with the technical gubbins underneath? I don't know. And this one is just saying that there's structure on that, and what's it mean to specify it. But then we have the specification of get of the methods, and in particular we're going to concentrate on get. I'm only going to do one. This one is when it's working. You have the map, you have the map proto, you know that this key is in that key value pair thing. You know this. This is awful. That's to do with the SMT solver. And you've got a proton object.proto. Afterwards, you've got the same precondition and the return value. This is the case where you have a valid key, but it's not there. This is the case where you don't have a valid key. So that specification, you know, it's certainly not great. We're not right there yet. We can hide that. What do we do about these things? How good can we get the SMT solver? I'm going to go very quickly through this stuff because this is now my talk's blown in terms of content. We want to handle the complex nature of JavaScript without simplification, and we're going to do it by compiling to a go-to language to cope with all the complexity of the JavaScript statements. The go-to language is going to have the same memory model, so that what's happening at the high level and the low level is going to work really well from the point of view of the analysis. And the go-to language is capturing the fundamental dynamic nature, extensible objects, dynamic properties, dynamic functions. I haven't said much about that. And we've got a JavaScript specific thing of how to cope with the internal functions. That means get value, put value, used in assignment, used everywhere. The point is you abstract so that it doesn't pop out in the developer. We annotate our JavaScript programs, pre-post conditions, invariants, and we have to do unfold and fold of predicates. If we were on specific predicates for specific data structures, we can make that automatic. At the moment, we put in all the predicates, so it just depends on where one needs. Of course, invariants, we know the issues, and pre-post conditions, how lightweight versus difficult are they? And we have a compiler. The compiler follows the standard line by line. How are we going to judge what it means that we're doing good analysis as an academic group if we don't follow the standard line by line? We do not have to be efficient with this. We have to be quite efficient and precise. We can be a completely different form of compiler compared with those macho compilers. Tested against the official test suite. Because we're theorists, we prove things correct. We've got the verification tool and these internal functions. So first on compiler, I really have to go quick now, time afterwards. I want to get to a demo and show you this happen. So we've covered a lot. We do continuous integrated testing. We know there's a lot of work here. If ES6, the new one, does proper filtering on commands so that we can analyze and understand the tests that are appropriate for us, which is ES5 strict. We can extend to ES5, we know exactly how. ES6 is double the language definition. We will move if people want us to. There's non-implemented features. We did a lot of coverage, not everything. Here's the compiler coverage. There's a little bit of faff. Here's the applicable tests. We've got them. Why can't, what's it mean to say which tests we pass and don't pass? As a theorist, I want to know. You don't see this even in the theory work. In people saying, we've done testing well, they say things like 30%, 70% coverage, something like that. We don't know what's going on in the 30%. So I really like that testing. The memory models are I'm going quick here, sorry. The memory models are the same at the two levels. In Facebook Infer, they are not the same. You've got SIL, you've got many languages to SIL. The memory models are not the same. You're collapsing stuff as you go to SIL. Give them the little lightweight bugs they're doing, that's just fine. If they want more analysis, at some point they're breaking and not fine. If you've got the memory models the same, suddenly you've got the assertions at the JavaScript level and the go-to level the same. There's nothing to prove. It's almost identical. So you can really get that result because you've got the definitions all.
When you say memory models the same, you talk about weak memory
No,
models?
I'm talking about just the definition of the memory model as this extensible object thing with the proto-chain. Yeah? And it's straightforward and easy. How they use it is not easy, but it's very simple. And then, so we can get this result under the assumption of the correctness of the compiler. This is, they are small definitions. It's not an issue. What's the real message? When you're doing your tool development, make sure you do it in such a way that the definitions are right. Why not? This is me with my theory head saying, what's it mean to push it into that practical work? The difficulty, at the absolute place where it's difficult, is what does it mean to say that the operational semantics or the compiler is correct? So what we did, line by line close to standard, tested with respect to the official test suite, take a fragment, hand proof, that's our particular head. We did not go all the way to COP development. We could. CompCert, 250 rules, lovely modularity. This stuff, 900 rules, no lovely modularity at all. It's only a bore. It's nothing more. It's doable. So then, how strong does one need or want to be? Well, we've filtered out the stuff so that this is the place where you choose where to be with complex, this is where the complexity hits. As whatever community you are, what does it mean to solve that bit? For those of you who know about separation logic, frame inference in the dynamic setting compared with the static setting is much harder. We've done it. We have a symbolic execution engine calling on an entailment engine. Anything to do.
When you say you've done it, like it's now a completely solved problem.
Well, I mean, we've done it for JavaScript.
Okay.
And then we've got another dynamic language. What's it mean to do it? But
cool.
Yeah.
Cool.
So, and can we use the go-to language that we've got now and put in another dynamic language? Well, you know, we're a small number of people. So how does one go to the next thing, and what does one do to argue something like that? Yeah.
Can you just give maybe a couple more sentences about why it's much harder in a dynamic setting? I think I kind of have a gut feeling, but I just love to hear your perspective on it.
Time. Properties are dynamic things. You're not just doing the frame inference on constant names. You're doing expressions. Doing it on expressions. That's hard. And you're incorporating this empty fields predicate, because you don't, what does it mean which things are there, which things are not there? It's a much more fluid thing, and so your frame inference, that question mark and what's it mean to make it, to find out what it is, that search and that finding is much harder.
Got it.
Yeah. You can read that diagram and ask questions afterwards. Internal functions, get value, put value, they're hidden by the developer. We don't, everything needs to be automatic from the point of view of that, and just done. Axiomatic specifications satisfied by implementations at the low level go-to language and verified. They're also tested, they're also blah, 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 blah. You know, you've got real validation of what that means. ECMAScript really likes this and wants to keep talking to us about this. I will. Because the old guard, small number of people, knew what properties they wanted for get value and put value. Now they've expanded hugely, and the young people don't remember those properties that need to be preserved as we keep on going and extending and adapting the language. So they would really like these to be, I'll show what we've really done. I'll show you the caveats of we haven't got everything yet, so we need to keep going. Yeah.
So I'm just curious, to what extent is the functions on this list and their properties defined by the standard? Or is this your admit?
All.
They're all
This and these are the arrows are the dependencies. This is all about the standard. We know them very well because we first did COP specification, and now we're working on verification, so we know them well. And this reference implementation, line by line with the standard. Yeah. So I want to show you a demo. Here it is, and basically what this is going to do, I'm speeding up, this is what's going to do, is going to fail. And it's going to fail because we haven't got it right. Purposely. So it fails. So let's assume things are working well. What are we going to do? There's this many lines of the trace. Life is hard. So we just had a fun and had a play, which is, you can't expect, certainly for now, we haven't got the error messages. We might be able to get the error messages. We're so tight. Control flow here, control flow here. Obviously more fine-grained here. We know how to relate them. So what's it actually mean that the errors here can lift up to here? We've got a student project on it. But for now, what we're doing is we've got another tool with Julian Dolby. The quick explanation is, if you know Rosette, we're doing that. And in particular, you've got a concrete concrete interpreter of GISL to Rosette land, and that gives symbolic analysis for free. That will do. But the point is, so then what happens is you've got programs with these symbolic values, and either you're going to get tick, that tick means tick up to the role of bound, you haven't got full, or you're going to get this counter model. And we're going to show you a the problem with